Bismillahirrahmanirrahim. How are you, students? Today we will study unit number 2, subject physics, chapter name kinematics. Topic is scalar quantity and vector quantity. First we will go into detail of scalar quantity, and then we will go into detail of vector quantity. So what do you think? What is scalar quantity? Those quantities which have magnitude but no direction. A scalar quantity is a quantity that has magnitude only and has no direction in space. Example of scalar quantity which is mentioned on the screen is length, area, volume, time, mass. You cannot predict that time is going in towards east, west, north, or south. You cannot say anything about the direction of time. You cannot predict the direction of length, area, volume, space. You cannot. If you can, it will be it will be other quantity then. It will not be these quantities. I means that it will not be length, area, or any of this. So those quantities which have magnitude but no direction is called scalar quantity. For example, length, area, volume, this one. Here you, with the help of this instrument, you measure mass. It is physical balance. It is a physical balance. So it make a comparison of known quantity and unknown quantity, of standard mass and the mass whose mass to be determined. And this is used for, is measuring cylinder used for volume. It cannot give you the direction. Time, clocks cannot give you the direction. So it's a scalar quantity. These are scalar quantity. So scalar quantity are those quantities which have magnitude but no direction. Vector quantities. A vector quantity is a quantity that has both magnitude and direction in space. Okay. Example of vector quantities are displacement, velocity, acceleration, force. You will study the detail of these things. For example, if you look to this diagram, pushing an object, force will be in this direction, in the direction of red arrow, which is already specified. This is the direction of force. So force, when you apply force, you must know the direction. The direction is known. So force is a scalar vector quantity. Now, one thing which I didn't explain in scalar quantity is the magnitude. The term magnitude means a number with a suitable unit. A number with a suitable unit. For example, if you write 25, I will write again 25 meter, displacement of 25 meter. So this is a number and this is a suitable unit. So a number with a suitable unit is called magnitude. This is the definition of magnitude. A number with a suitable unit is called magnitude. If you want to specify force, you will write 10, any number, and Newton is written with this one. Newton. A unit with a suitable unit, a number with a suitable unit is called magnitude. So vector quantities have magnitude and direction, and scalar quantity have magnitude but no direction. Scalar versus vector. Scalar have magnitude. Only having magnitude is called scalar quantities. Having magnitude plus having the direction is called vector quantity. Force have magnitude as well as direction, so it's a vector quantity, and magnitude only scalar quantity. Pressure is scalar. Area, volume, length, mass, time, temperature, these are scalar quantities. Force, velocity, acceleration, you will study these topics. Just uh, think that when force is applied, it is applied in a particular direction. So it have magnitude and direction, so it's a scalar vector quantity. And length don't have direction. When it have direction, it is called displacement. So length have only magnitude, so it is called a scalar quantity. So here a little bit detail about vector is written. So you study it by yourself and do it. I will just read, and if there is necessary explanation, I will make those explanation. A vector is an object that has both magnitude and direction. Geometrically, we can picture a vector as a directed line segment whose length is the magnitude of the vector and with an arrow indicating the direction. Direction of the vector is from its tail to its header. A vector with the value of magnitude equal to 1 and direction is called unit vector. It's not in your syllabus, but just learn it for the knowledge. The second paragraph is not in your syllabus. Just for information or for knowledge. Here it is written unit vector. Unit vector is a vector which have magnitude equal to 1. Magnitude equal to 1. Unit vector, if you write unit vector is represented by I. If a unit vector is represented by I, so you will put a cape over it. It is called cape. It is called cape. I cape. I hate. H-A-T hate. So it means it's a unit vector. If you write J, it's a unit vector. If you write K, and you put cape over it, it's a unit vector. It's a unit vector. So any symbol written with a hate or a cape is called a unit vector. Unit vector have a magnitude equal to 1. Unit vector have magnitude equal to 1. Now, they speak about tail and head. So I will give you the information. It is also not in your scheme of study, but you need it. So that's why it should be considered in syllabus. Tail, vector tail, and vector head. You draw a simple line like this. It's a not it's not a straight one, but consider a straight one. This is called tail. This is called tail. T-A-I-L, tail. Tail of a vector. This portion is called header. H-E-A-D, header. Head indicates the direction. It is called header. Now next, position. The place where someone or something is in relation to other people or things. The place where someone or something should be. The way someone stands, sits, or lies down. the location of an object with respect to a fixed point. So you study these definition. I will explain that if you are here, if here this is, let's say this is a room. This is a room and door at this place. And door is at this place. And you are sitting here. If you enter through this way, your location is to the left of the door, 2 meter or 3 meter, whatever the distance is, 2 meter or 1 meter or 1.5 meter, 14 foot, whatever the distance is. When you are entering, you are to the left of a person entering into the door. This is your location in the room. For example, this is your home and your school is here. You are going in this direction and then going in this direction. You reaches your school. So this is the location of your school with respect to your home. So location is the situation in which a body is. Location of an object with respect to a fixed point is the location of an object with respect to a fixed point. With respect to a fixed point, you can take any fixed point, and if you specify that object A, let's say an object A is lying at 2 meter towards north, towards east, or at 30 degree, anything with respect to point O or any other point, you fix it. You fix it is the position. In easy words, you can say that the location of an object with respect to a fixed point. Location of an object with respect to a fixed point. If you take this fixed point, this fixed point, this is your fixed point, this, and you specify the location of your school with respect to this point, then it is called position. Specify your position with respect to the school, or specify your school location with respect to your home location. That will be the position. Now comes towards next topic, distance and displacement. Distance, a scalar quantity measuring the total length of an object travel. Distance is the length. Displacement is also the length. Both are length. Distance is scalar. Displacement is vector. Displacement is vector. Distance is scalar. Distance is length. Displacement is also length. But distance have no direction and displacement have direction. Distance is the actual path traveled by a body, and displacement is the shortest distance between 2 points. So displacement is the shortest distance between 2 points, and distance is the actual path traveled by a body. Distance is measured in meter. Displacement is also measured in meter. Now, in next example, there are some examples which I will show you, and I will specify. I will give you the concept of distance and displacement. This is a table in which a little bit information, differences and similarities are written. Distance is the length of the path traveled by a body while moving from an initial position to a final position. It means that the actual path traveled by a body is called distance. Displacement is the shortest distance between its initial and final position. Distance is scalar, displacement is vector. Distance is measured will be always positive. Displacement might be positive, might be negative. Because it is a vector quantity, so if you reverses the direction, its value will become negative. Total distance is equal to the algebraic sum of all the distances traveled in different direction. The net displacement is the vector sum of the individual displacement in different direction. Displacement is a vector quantity, so you take the vector sum, and distance is the actual path, so you should consider each step, whether it is in opposite direction or in one direction or other direction, whatever the direction is, but it should increase the value. There is no decrease concept on reversing the direction in distance. There is always a distance covered whenever there is a motion. Displacement will be zero if the body comes back to its initial position. Unit is meter, unit is meter. I will explain these points in the coming figures. Now, distance is a scalar quantity where displacement is a vector quantity. Distance and displacement is shown in the diagram. The red line, this red line represents the distance because it is the actual path traveled by a body. And this is the shortest distance. This is the shortest distance, and it is displacement. It is the directed length, shortest and directed, so displacement. And this is the actual path, so it is the red line represents the actual path, so it's a distance. These uh, these these students are observer travel in this direction from one tree to the other tree, and then in this direction 4 meter they travel in this direction 4 meter, and here they travel 3 meter. So the total distance is 4 plus 3 is equal to 7 meter, and this is the displacement because it is the shortest distance, so it is 5 meter. So distance here is 7 meter and displacement is 5 meter. Now you I think so you better understand now. Now in this case, this student, this person, this boy start from point A, goes in the upward direction. You should follow the direction of the arrow. 3 meter, 5 meter from B to C, and from C to D 3 meter, and then from D to A again 5 meter. So 5 plus 3 plus 3 plus 5, it will become 10, 16 meter. So distance is 16 meter. Distance is 16 meter. But when he takes start from this position, then go to this position, then come this position, and then back to its original position. So initial position is this one. Final position is also this one. So displacement is 0 because final and initial point is same. In this case, the bodies take start from A, covering 3 meter, then 2 meter, then 3 meter, then 2 meter. So it will become 3, 3, 6, 7, 8, 9, 10. So distance is 10 meter, but displacement is 0 because initial and final position is same. Initial and final position. The shortest distance between initial and final position is called the displacement. So initial and final position is same, displacement is 0. Now in this case, initial position is A and final position is B. This distance is 5 meter. So displacement is 5 meter. This is the distance traveled. This is also traveled by the body. And this is also traveled by the body. So 10 plus 10 plus 5, it will become 25. So distance is 25 meter. Distance and displacement traveled by AB. The bluish line, this bluish line represents the distance traveled by the B, random motion. This is the final position. This is the initial position. So the bluish line represents the distance. It is labeled bluish. So it represents distance, and the pinkish or purple, whatever you call it, I think it purple. This color represents displacement. Now a sheet have been given on the next page. Do it and take it as home assignment. Here distance is given. Distance versus displacement. Yes. Scalar or vector. You should take any one of this. Distance is scalar or vector. Write the unit of distance. Write the formula for distance. Which instruments is used to find distance? Symbol. So write the scalar or vector, scalar or vector displacement, choose any one. Write the unit, write the formula, which instrument is used to find displacement, and symbol. You will do it as a home assignment. Okay, now speed is the distance traveled per unit time. If a body covers a distance of 100 meter, a distance of 100 meter in a time of 1 second. Unit time means 1 second. Unit time means 1 second. A body covers a distance of 100 meter in 1 second, its speed is 100. If it covers 100 meter in 2 seconds, its speed is, you divide 100 by the time, you will get 50. So speed is 50 then. 100 meter in 2 seconds. Then 50 meter per second is the speed. 100 meter in 1 second, it means 100 meters, the speed is 100 meter. Speed is a scalar because from speed meter you cannot measure speed. If you keep your eyes on the speed meter, you cannot predict the direction. And that is the magnitude of the velocity vector. Scalar quantity, that is the magnitude of the velocity vector. It does not have direction. Means that is the magnitude of the velocity vector. It means that speed of a body in a definite direction is called velocity. If speed have direction, it will be velocity. If speed don't have direction, then it is called if distance covered in unit time without direction, without knowing the direction, without having the information of direction, then it is called speed. Higher speed means an object is moving faster. Lower speed means it is moving slower. If it is not moving at all, it has zero speed. Formula, it is written V is equal to S divided by T. You can see in the diagram v is equal to s by t. The most common way to calculate the constant velocity of an object moving in a straight line is the formula, and which is written in on the whiteboard on the screen, where v is the speed, s is the distance moved, and t is the time it takes to complete the movement. T represents time, s is the distance, and v is the speed, velocity. The speed of a body in a dependent direction is called velocity. Speed is the distance per unit time. Velocity is the displacement per unit time. The displacement covered by a body in unit time is called velocity. Mathematically, we can write velocity is equal to displacement per unit time. Velocity is a vector quantity. So it is written in bold place italics. Here is a comparison difference between speed and velocity. Speed is the quantitative measure of how quickly something is moving. Velocity defines the direction of the movement of the body or the object. Speed is primarily a scalar quantity. Speed is a scalar quantity. Velocity is a vector quantity. It is the rate of change of distance. It is the rate of change of displacement. Speed of moving of an object moving can never be negative. Velocity can be negative. Velocity can be zero. Speed can be zero. Velocity can be negative because of direction. If you reverse the direction of velocity, you will get a negative sign to the velocity. So here the negative sign means direction. Speed is a prime indicator of the rapidity of the object. Rapidity, how fast an object is. It can, velocity is the indicator of the position as well as the rapidity of the object. It can be defined as distance covered by an object in unit time. Velocity can be defined as displacement of an object in unit time. Both have same unit, meter per second, meter per second. Speed here is also measured in meter per second. Velocity is also measured in meter per second. Speed is scalar, velocity is vector. Speed is distance per unit time, velocity is displacement per unit time. Speed cannot be negative, velocity can be negative. Speed can be zero, velocity can be zero. Both are measured with different instrument. Thank you, students. It's today topic, and do revise. I hope so you will understand. So wish you best of luck.